hopefully you're not too sad about that. Okay, so I'll just kind of go through pretty much in order that I have them on the uploaded, and there's a few that I didn't get slides for yet. Maybe for you guys, just bring them up and use your laptop. So for ACTN, you guys ready? Judges, are you ready?
Okay. Good afternoon, everyone. Welcome to Hackathon, and my name is Hao Mian, and I'm going to report the ACTN progress. So this is a continual work based on the previous Hackathon, and this time we focus on IP and optical network together. And the people did some offline work to discuss about the scenario we are going to test and the model we are going to use. So after we reach an agreement, people go back home and do their own implementation job, and they bring their controllers here for the kind of interaction and the test. So people also agreed to test the 4 different scenarios with 2 different approaches, including RESTconf protocol and the PCE protocol. So the 4 scenarios we are going to show here is topology abstraction, end-to-end service provisioning, bandwidth adjustment together with interdomain recovery. So the message involved is highlighted by the red characteristic, and the corresponding draft are listed as a bottom of the page. And we are developing based on the owner's platform, and this is a snapshot of our GUI. So during this weekend, we do meet some problems, and the biggest problem we found is a kind of mismatch of different versions of Young models. As you may know, the T topology, we focus on T network. The T topology is augmented from the network topology, but unfortunately, they are not consistent with each other on the notification problem, which means when we want to notify the node change, there isn't a complete information to be reported to the controller. So to tackle this problem, we implement the TE node ID by including all the base information in the network topology model. And we also need to share some of the experience during our implementation, because we really deliver the same Young files to different teams, but we find that each developer have different understanding and assumptions so that their controllers cannot interact with each other. To accelerate the progress, we exchange the JSON output within our team for alignment, and this really accelerates the progress. So we hope IETF can consider some kind of reference implementation in XML and JSON file, and that will be helpful for both understanding and implementation. To summarize this, in this project, we achieve ACTN interop in multi-domain, multi-layer network, and the function including learning topology, creation virtual network, and the virtual network updating. I think it achieved via both RESTconf and the PCE protocol. There are a few action items we are going to deliver in the upcoming IETF meetings. Firstly, we need to feedback our progress to some working groups and talk with TIS working group, I2RS working group about the notification mechanism misalignment. And we also need to report our PCE progress to PCE working group. After people reach an agreement, I think we can update the corresponding draft to better move forward the standard work. And we will work closely with IETF and to try to have more vendors and operators into our interop future plan. And we will also continue to contribute the code to the ACTN Owners project, which is running in Owners. The latest progress of this interop test will be updated to the ACTN wiki page in this link. And I would like to take this chance to thank for all the team members. They do a great job. Not only the on-site people, but only a lot of people offline. We did by teleconference and other stuff. And finally, it is a friendly invitation to Bison Bytes demo on Thursday night. All of you are welcome to visit us. Thank you.
Yeah, just stay up here. Did you guys have any questions? Yeah.
Okay, thank you.
Okay. So how about service function chaining dev kit? You guys ready? Okay. All right.
Hi, everyone. My name is Kyle LaRose. This is my first hackathon and IETF meeting, so it was pretty awesome. Thanks for having me. I worked with Dave here and Pierre on the service function dev kit, and it was basically taking some work that Dave and I had done and integrating it with FDIO's or Fido's VPP. Fido is the little dog logo there, pretty cool. All right, so what was this hackathon project about? At Sandvine, we've been working on some service function chaining stuff for the last year, and we've noticed that there's kind of a dearth of service functions out there. We hadn't really found any open source implementations or references of service functions. And we're thinking that it would be pretty cool if people could easily develop new service functions, test out new service functions, and do it in an efficient manner. So the main goal of this hackathon project was to make it easy to integrate with classifiers and service function forwarders for testing and proving service function concepts, and make it simple and easy. So we built an abstraction for writing a service function, and we used VPP to get the traffic from the NICs, from the wire into the service function and back out efficiently. And in doing this, we also wrote some toy service functions to sort of, as a proof of concept, show that you can do it and that our abstractions work. And the two we wrote were a simple count application, just counts the packets that are coming in, and a service function that sends out resets, which is basically combines two concepts that are important, which is the ability to inject packets into a path and the ability to reverse packets. So say it's coming in one direction, I want to send a packet backwards through the service functions that had preceded it. So the team, as I introduced Dave, myself, Pierre, and Shweta, sorry, I forgot to mention you earlier. Anyway, what did we actually achieve? Well, pretty much everything we set out to do. Yay. So we had our test applications running and working. VPP uses a shared library interface to load multiple service functions from its command line. And in particular, to sort of work with, interoperate with the traffic steering engine that Sandvine had implemented, we needed VPP to support NSH over Ethernet. So we added that. And we also needed to have VPP support sending NSH traffic to a sort of local service function. And that's that shared object plugin I was talking about. So we did all that. And then we added a VPP integration layer to the sort of dev kit that Dave and I had worked on earlier. So design-wise, you can basically see that, as I said, packets come into VPP, into the NSH SFC plugin, into the NSH SFDev plugin, and then get distributed there to the service functions that have been registered with it from the command line. And overall, it was about 1,200 lines of code. Pretty cool. I'm assuming that's like word count -L. I'm not sure, but anyway. So to actually test all this stuff out, we had a private cloud running. basically a Linux box was connected to our traffic steering engine, which is a classifier in SFF running in the data plane. And then that would send over a virtual switch to these Linux boxes running VPP. And those would, act as service functions and send it back, and it would all work. So we could send pings through it. We could SSH. It was pretty cool. Did I miss something there? No, I didn't. Okay. So regarding the the actual working group stuff, Pierre had never really done much research into service function chaining. He read the NSH spec, liked it, very good. So had some good feedback. I've read it myself a couple of times, and I think it's pretty simple. It's nice to read. One of the things we did for reversing packets was we used an expired draft, which talked about algorithmic path reversal. So basically, given it is sort of just an algorithm based on the service path to figure out how to inject it backwards without much or any control plane interaction, without any metadata carried in the packet. So it makes it really simple and easy to support functions that require reversing the path. So we're thinking that we pretty much proved that it worked pretty well. It might be worth reviving the draft or revisiting it, deal with any comments that had come out of it. And another thing we showed was successful interoperation between between Fido's SFF implementation and Sandbine's classifier in SFF. We ran into one hitch, which is that our proprietary OAM protocol, which we use for sort of data plane keep lives, doesn't really interact well with other SFFs. I think the feedback we can give from that is maybe we need a better standard where people have thought through all the problems with data plane keep lives. Right now, most of the OAM specs talk more about a lot of control plane interaction. It's not really what we needed here, so we should probably look at talking to the working group about that. Anyway, I'd love to give you a demo, but we don't have one. Trust me, it works. Maybe the bits and bytes we can show something. Anyway, thanks. Any questions?
Okay. So next up for I2NSF.
Sure. Okay, thank you. Hello, everyone. My name is Paul Jung from Sungkyunkwan University in South Korea. Behind me, there are my team members. So my students and the researcher in Korea Telecom, my students, also professors. Okay. Hello, say hello. Hi, welcome to Korea. Yeah. So basically, this IETF hackathon, the I2NSF working group, this is the first participation. So I2NSF chartered to use the NetComp and the LessComp plus data models, young data models. So the question is this approach reasonable for management and operations for security services? The second one is better than writing another security protocol. The third one is can we get I2NSF key data models such as Yang-based capability model and put open source code for I2NSF framework into our open source society. So result is we found the I2NSF working group approach works. So we can provide a fast time to market. So network management and operations should expand their work into security society. Also, we will follow up with other IETF working groups related to security, malware, scam, dodge, and then SEC events. So this work is done by students. So this is, I think, amazing thing. So this is a post. And let me quickly introduce what is the network security function. So this figure, the packet comes in and the switch. So how to do? First of all, it forward packet to the network security function, such as a firewall. And then if this is enough or not, no case, we forward the packet to our DPI, deep packet inspection. And then if this is a valid packet, and then forward back to switch, and then finally forward to our destination host. This is a network security function. So to go over this hackathon project, given the source code base for I2NS framework, we want to implement the two security services. The first one is the firewall for web filtering. The second one is the DPI service, VoIP LTE security services. So contributions in this project, so we proved the concept of I2NS framework. The second one is the validity of I2NS interface design. The third one is the feasibility of data-driven approach using Yang for network security services. So we used the open sources like this. And then the scenario of security services in I2NSF testbed, you can see we have this I2NSF network, such as the enterprise network. So top level, it has I2NS user, which means decide security policy. The policy is forwarded to security controller. This is the main entity. This high level policy translated into low level security policy and then delivered to network security functions such as the firewall and the DPI. And then security information is also enforced using the SDN network. So this hackathon, we implemented the two security services. First one is a time-dependent firewall service, such as we want to block the traffic access Facebook or the YouTube during work time. Otherwise, we can allow. The second one is the VoIP LTE security services. We try to block the hackers, the invalid voice call over some other continent countries, such as Africa. So lessons from this hackathon, we proved concept of I2NS framework is valid. So we use the open sources such as CompD for NetConf, OpenDaylight for SDN switch. Also, we use the Mininet for virtual topology, and also we use the REST API for I2NSF client-facing interface. And also we valid I2NSF, the interface design works. We have currently 3 interfaces. First one is a client-facing interface. The second one, the NSF-facing. The third one is registration. So this hackathon, we showed the feasibility of 2 interfaces. The third one is also we showed feasibility of data-driven approach using Yang to configure network policy. So this is the demo. So you can access this YouTube clip, and you can see. Also, we plan to show demo in bits and bytes. Thank you for your attention. See you soon. Thank you. So any questions? Okay. Okay. Thank you.
Okay, PCE. Yours,
yes.
right there.
Yeah, it's just me. Sorry. No backup dancers. Next time, maybe. So this is PC. It's good to be back to Hackathon with PCE. And so the path computation is just a very basic thing that any network controller needs to have. And path computation is one of those basic functions. Recently, in the last couple of years, PCE has also been extended to become more stateful, move towards more controller in such a way that the PCE can not just compute path, but also initiate new LSPs, make changes to that LSPs dynamically based on various requirements from the application. We have also been working in TEAS and PCE working group in something that we call as PCE as a central controller, where we move the PCE architecture more towards, more aligned to the SDN, and think about, can we use PCEP as a southbound protocol and use PCEP as a way to control not just the head nodes, but also all the nodes in the network while you are setting up the paths. So this we feel is one of the ideal ways to transition to SDN networks. While you have your existing network, you want to introduce SDN concepts by reusing existing technology, existing protocol, and without changing too much to your networks, and add programmability to your existing network. So that's the concept of PCCC. So at this hackathon, what we did was we took two problems. One is taking care of scheduling of TE resources. So not just computing path based on what is available right now, but start looking at future. So somebody requesting us that, oh, I would like to set up this path at this particular time with this recurrence. So we do path computation, not just on the TEDB right now, but time-based TEDB. So that's our first problem. And second, we worked on LSP control request from PCE. So let me actually go to the slides to explain them. That's much better. And some of the participants are listed from Huawei, China Telecom, ETRI, and SKT. So the first problem, which we call as scheduling, is basically the ability to schedule future reservations of TE resources. So ability for me to say to the controller that I would like this LSP to be set up at this particular time, and it should be alive for this duration. This is the sort of recurrence that I would like to have. And also not just set up the LSP at that particular time, but also say what will be the LSP path that I would set up in future, so that the customer can be aware of that path. And you are looking at path computation on a TDB, which is time-based. So that is what we worked on. This has actually been discussed in the TEAS and PC working group for a while. We had multiple approaches, and we finally reached a consensus that the PC-based approach is the right way to go. And that's what currently is in the TEAS document. And the main discussion that we had during the hackathon was related to the data structure. How do we handle this time-based TDB data structure? What is the right way to implement that? And what are the implications of that? So that's what we discussed. We hope that, though this is very implementation specific, it doesn't impact the protocol, but we were hoping the architecture document can talk about various things that we need to think about while we are adding time to our existing database like TDB and LSPDB. This is on the right hand side. What you see is the CLI that we added, which had start time, duration, calendaring, things like weekly, daily, and all that details. And once you configure, you can see what is the path that we will set up in future, and that option is also available. And when the time comes, the PC will automatically send an initiate message and set up the path at that time, and also tear down once the need is over. And we use the Huawei sandbox to get the topology, use a controller on our machines here, and get this topology done. So the second problem that we worked was initially sort of owner specific, where we realized that multiple instances can sometimes form a cluster, and multiple PC instances are working together in owners for scalability, as well as to make sure that one instance goes down, some another instance can take over. But the PCEP protocol, when it was originally written, it was from the point of view of PCC. That is, it's only PCC which can decide which PCE is in control of its LSP. But when you have a clustering, and in that clustering, these PCE instances can use their own algorithm. So in case of owners, they have a mastership algorithm, and they use this algorithm to figure it out which PCE becomes the new master when the primary has gone down. And in this case, we wanted the PCEP protocol to support another PCE to take over control of the LSP. The same also holds good for load balancing. If for scalability, if I want to virtualize my PC and add one more VPC instance in my network, and I want this new instance to take over control of some of the existing LSPs in the network, I wanted that option. The new instance, when it comes up, it can request, oh, I would like these LSPs which were earlier in control of another PCs to now given to me. So these are the two things that we added. This document is also in the PC working group agenda. We will plan to add the implementation section and provide details. And we realized that this problem is not, initially we thought it's owner specific, but we are realizing that this is very common. It can happen for any type of controller. Any controller that would like to have an algorithm among the controllers to decide who's the master, rather than leaving each device to figure it out who should be the master, which is much more difficult to do. So I think that's will finish it. Thank you. Any questions for me? Thank you.
Okay, the Cozy Jose. This one or this one? Probably this one.
Yes.
Hello, I'm Matt Miller. Jim Schott and I came here to work a little bit on Jose and Cozy. Jose stands for the JavaScript JSON object sign-in encryption. It's a enveloping format for protecting content that's supposed to be a little bit more web-friendly. Cozy is the CBOR object sign-in encryption. This is a format, an enveloping format for protecting data that should be friendly for IoT devices. So coming here, our original goals were to try to put together some sort of interop test, but this kind of fell apart when time constraints kind of got in our ways. But what we ended up working on here was adding some more to our test cases that already exist out there, getting a little bit further on some of our existing libraries, and some work on docs, whether this was to review or start implementing some of the things that are out there making use of Jose or Cozy. For our test cases, we added a few more to the existing Jose test case set. We put in a set for testing the unencoded payload option. This is where you can, in Jose, there's a definition that allows you to send the payload, instead of being base64 encoded, it's raw, and sending that through, and there's some test cases for that. And this also, we added a test case for the curve 25519 ECDH, and a test case for the EDDSA 25519. And these are all formatted and already uploaded into the cookbook available on GitHub. As far as library work goes, so one of the major ones was updating the various Cozy libraries to match the current IANA assignments for message tags. And that's already up. And for a CJose, we did a couple of fixes to some memory oddities that were in the library. And those are up there also. Doc work. There's an initial implementation that Jim started working on for ad hoc. That's based on his C# library, and from that he's got a bunch of feedback he'll be able to provide to the authors. That's as far as we got this time. Hopefully next time we'll be able to actually get our interop thing actually going, but at least this time we made some progress and have an idea of where to go next. Thanks. How many people were involved? There was, besides myself and Jim, that we had Phil and Leif, and I think there was one other person that showed up, but I didn't catch their name. Oh, and Karsten Boardman came by to work on some things. So Cozy and Jose is already closed. Jose is already closed. Cozy is about to close. There's and Jim's providing some feedback to the authors, but it's not directly related to a working group, but it is a individual draft.
So our other SFC presentation.
Good afternoon, everyone. My name is Wenbu from Sonsei University, Korea, and this is my first time, my first experience at the hackathon, and I had to admit it is very interesting and the time is very tight. So today our team bring here 3 projects related to SFC and its implementation in Open Daylight and ONOS. The project includes hierarchical SFC, controlling service function access to NSA header, both of them using Open Daylight, and another one for calendaring in a smart SFC using ONOS. So the first project we have here is the hierarchical SFC with the flow stateful classifier. Basically, this concept is aiming to distribute the control plane of the SFC for the ease of management. So we have to deal with some problem here when we have to maintain the appropriate SFC related information between domains and in multiple management domains. So I don't want to teach fish to swim. So we have the first author of the draft hierarchical SFC here, Mr. Dave Johnson. Thank you for your discussion to help me come up with the idea. So the second project I have here is the search function access control to NSA. This project aims to solve one of the problems in the previous project. When we have multiple domains, then we have to maintain the multiple scheme of metadata, SFC metadata between domains, and we need some mechanism to protect the data when it's crossed the multiple management domain. We have implemented it into one scenario where we have 2 domains, and the top domain will have to check the security, the access control of the second domains. We have implemented successfully using Open Daylight. However, the time is very tight, so we don't have enough time to make the API or the configuration part. But also after in the development process, we realized that we need a agile model for the access control list of the service function. So it would be an interesting idea in the working group. So the result here is actually very difficult to see because we have to look at the flow table or the packet capturing. So if you're interested, we can show you a demo after. So the last project, please welcome Mr.
Thank you, Victor. Before I go to the problem statement, I'll introduce myself. Myself, Sarup. I work for Huawei. I came here first time. So before start going to the problem statement, I just want to describe the Smart SFC. This is a GUI-based solution based on ONOS, and this is intent-based SFC solution. So here we monitor the SF health, and based on this we decide which SF to choose, and also we support the protection and load balancing of SFs. So here also we do dynamic SF allocation and deletion. So for Hackathon, this is a small feature I developed. Also with me, two of my colleagues in Huawei India, they helped me, Nabin and Vikram. And in this calendaring, we basically give the feature like this is like SFC scheduling within some time range. And so SFC chain will be scheduled within that time range we mentioned. And also inside the time range, you can give the repeat option, and where you can say like from this time to this time every Sunday, let's say this SFC will be scheduled. So these are the two things we developed. And right side of this, we have some GUI. Here, the first picture, there we configure the calendar and mention the time range. And second one is the path is not yet scheduled. And the third photo is path is scheduled on that time. And again, it has been withdrawn after the time expired. That's it. If any question. Yeah. We are just friends. It's not related. One is first two projects are based on Open Daylight, and third one is ONOS. Okay. For SFC protection, actually we are still not developed yet. This is using some draft written by Gaurav, and still it's not developed on. Any other? Thank you. Thank you.
Okay. And MPTCP. That's, sorry, I misspelled it. I'll figure that out later.
I just need to get rid of the black thing because otherwise it's going to defeat. Yeah, okay.
Wait a minute, make it bigger.
The green one.
What was the black thing?
Perfect. Yeah, because with the black thing is going to be difficult. So, hello, my name is Fabien Duchesne. I'm from UC Louvain in Belgium, and I will present you what we've done on the hacking the MPTCP socket API. So first, I will just present what's MPTCP because, yeah, it will be easier to understand what we did with the API if you know what it is. So multipath TCP basically is an extension to TCP designed to allow you to establish multiple paths between peers. So if you take my phone, for example, I have two interfaces, Wi-Fi and LTE. But if you establish a TCP connection, you will always have only one connection between source and destination. Here I have two. So we developed MPTCP, which basically bundle the two paths. You don't change anything on the application at first. So as it's implemented, the application will just open a TCP socket. And in the kernel, we added the MPTCP that will just translate and use multiple TCP. We call that subflow. So if you have an MPTCP connection that consists of multiple TCP connections, the TCP box are basically the subflows. So it's transparent for the application. It's all in the kernel. About how to establish subflow, for the moment, the kernel makes the decision. So in the default mode, for the moment, we call it full mesh. We will just establish, if I go back, you will just establish a full mesh between the interface in the server and the clients. So the kernel making all the decision was sometimes not desirable. So what we did is we added the API. It's also in the IETF. I forgot to say MPTCP is there is a working group here, and we have RFC for the API too. So the API basically allows the application to take some control about how MPTCP is working. So for instance, I want to add one connection or not. So the API in orange here just steps up to MPTCP and adds more connection comments like add subflow, remove subflow, and other things. So About the hackathon now. We are only 5 or 6 here, but we are from Belgium, where we developed the main MPTCP implementation, and we ask our undergrad students to participate to the hackathon. So we are only 6 here, but there are 25 people with us in Belgium. As there is 8-hour difference, basically they work when we sleep and the opposites. So that's pretty convenient. So what have we done? In Belgium, they use the API for Hyper-3. They also add some bindings to allow the API to be called from C#, Java, Python, and Ruby. They also modified some application to be able to use the MPTCP API. So they modify the OpenSSH, they modify curl and LightTTPD. In the case of LightTTPD, basically now the server is initiating the step flow, so the TCP connection. On our ends, we think differently. Like, there are a lot of applications out there, and sometimes it's difficult to modify them. I don't know if you already tried to open the SSL code base, the OpenSSL, but if you didn't, don't. So we're like, okay, there must be another way. So we thought about LD preload. LD preload, basically, we did, okay, we will do a library that you can call with LD preload. And this library, we just take care of calling the API instead of the application. So you just load the library with some parameters like, I want to be aggressive, I want to use a full mesh, I want to do that. You can stop some parameters, and the library will basically intercept the call, so your connect call, your read call, and other things, will translate your call into MPTCP API call. So it allows unmodified application to still use and benefit from the API, in case you don't want to modify it. So if you see on the thing, the add subflow is now done via the library and not directly the application, so you don't need to modify the application. The takeaway, so we are glad about the iPerf extension because it will make easier benchmark for us. About the API now, it was difficult for us to do our LD preload thing because for the moment the API doesn't allow to send notification, callbacks, or error codes when you do a connect, for instance. So it was pretty difficult to develop the LD preload. So in case of the API, one of the takeaways we have now is we need some callbacks from the API, and it's been implemented. It will be added in the working group. So yeah, we'll learn things about the API, and that's good. Also, inferring new endpoints from the library perspective was difficult. So which IP to use when you hide everything for the application, sometimes it's difficult to find endpoints. And it's 5 minutes, so that's it. Thank you. Any question? MPTCP. Yeah. On the main slide, there is a draft about the API. Yeah, I didn't put the RFC for MPTCP is 6824. Yeah, I didn't include the MPTCP one, but the draft from the API is there. That's the API we used. Please, we have students at? Yeah, I mean, we have students from the UCLs from our university, the university that contribute to develop the main Linux implementation of MPTCP. I'm also one of the guys maintaining the main implementation, and we contribute to the working group. So tomorrow I'm presenting something. So we informed our student that, yeah, UCL is doing that. Do you want to participate in the hackathon to use the API we specified? And yeah, amazingly, we had a lot of students that wanted to participate, and we're very different levels. So some of them are really contributing, and some others are just learning what it is. So that's pretty cool. I mean, it's a success for us having that much students participating. That's cool, and introducing them to the hackathon and to the IETF. So yeah, we're pretty happy about that. Yeah.
We're able to actually use iPerf to show like a decrease or improvement or
yeah. Sometimes you actually use iPerf because it's easy to fill the cable with iPerf. So yeah, I mean, it's not the only test we do, but sometimes when you want to get a sense if some things we are adding works or not, yeah, we use it. So for the moment, iPerf was just using all the links. here with the API, yeah, we will be able to fine tune where it's rough benchmark, right? It's not in details, but yeah, I mean, when you want to go easily and fast, IPF is useful. That's bulk transfer. So thank you.
Okay, well, we'll see if it works better for you. And, oh, wait a minute. Yeah, that's right. We'll see. Thank you. All right, so what I want to do is provide the outcome of the Yang table over there. So what we've been doing is some toolings around Yang. What we have to understand is that in the world of Yang data models, in data model-driven management, we want to work with data models, then we want to configure devices with netconf or rasconf. Then you want to encode this into XML or JSON, then you want to provide the API. So somehow my message is that your automation is as good as your tools. That's why we're spending multiple IETF hackathon working on tools. The first one I want to show is this one by Joe Clark. It's pretty useful. So, and I'm not sure. All right, I need to duplicate this. So it's a tool basically to tell us what are the bottlenecks into those old data models. Right now, I've got a pile of data models, right? So which one should we focus on first? So typically, you load a series of models, right? I know that all these models at the top, they're a package, right? So what we could do with that is see the dependency. Typically, I'm going to look at the red one. The red ones are the RFC. So the RFC are kind of done. Okay, so there what I have is the one with the black circle means this is the first Yang models you have to solve in order to publish all the other ones. If you browse over this, you're going to get the draft name. So as an AD, this is very interesting to tell, okay, this is the next draft that the working group have to focus on in order to solve all the other bottlenecks. The second tool is, again, done by Joe Clark. This is a database search. So, you know, from time to time, you want to see, is there already like a different type, depth, or a different group or feature defined anywhere in the industry? So what you could do is search on anything that you want there. And it could be any of the keywords in Yang. I want to have a grouping about VLAN, for example. I want to see if there is a type definition with a VLAN. You can just type VLAN there, do a search. It will get you all the different data models with all different links. Then you can browse through the models and see if it's exactly what you want. You know, with more than maybe 1,000 Yang models these days, I mean, this is a real useful tool. The issue is to make sure that all these Yang models work together. Now, on the compilation front, what we've been doing is I've been adding to my website multiple compilers, right? So typically now we have Pyang as a compiler. We've got confdc. We've got another one I did this weekend, Yuma work. We are working on a fourth one, Yanglind. The goal is that now we're comparing the result of all these compilers for all the Yang models on a regular basis, and we can directly send the feedback to all the authors.
Now, okay, I covered a couple of tools already with a demo. And what else? Just one second. All right, this is done. Hello. And this is not responding. All right, the Yang catalog is a tool also to populate all these Yang models from the industry in order to serve the database search that Joe created. We're working on this along with all the metadata we could find. Is this an RFC? Is this a document? What is the draft? What is the maturity level? Is this implemented? And all this. This is based on the open config metadata. So if you combine this with the tool and the visualization, it starts to be a great set of tools. All right. A team of 4 led by Chin has been working also on publication of these statistics. Now the added value there, this is per working group. And now we could have the same type of functionality, but added to the tracker. So directly we could see these are all the tools that we have for a specific working group and the dependencies. Very useful as well. And again, it tells you like the compilation errors. Now, the next step is that in the tracker, what they want to do is add the link per working group. So pretty useful again. Again, this is in the middle of a code sprint and hackathon. I don't believe there's a difference in any way. Now, so I told you that we've been adding new compilers. Everything there is new. We also have new industry using those Yang models. We compile them. We give them the feedback, for example, on ONF now. And we've starting this work actually a bit earlier on this hackathon, like last week, and we've been able to compare the result of compilers and solve the bugs already in a couple of compilers. So this is a great advantage for anybody doing Yang in the IETF. And now, Gaurav, do you want to just discuss the 2 slides?
Thanks, Benoit. Okay, so as a part of this hackathon, we have implemented Yang deviation in the ONOS Yang tool. This is basically to generate the deviated metadata schema, which is to be consumed by the common driver framework, which we are working as of now in ONOS. The common driver basically aims to remove the driver implementation specific to the devices. So for any new device coming up, the integration of the device to the controller can be fastened up. So for this particular thing to happen, we need the model mapping framework to be there, for which the Yang deviation is a first step. The code is put into the private Git. And one of the takeaway what we have for this particular problem statement is we found that for the model mapping framework, Yang deviation may not be the final approach. It doesn't cater to all the scenarios of the model mapping. So maybe in the future, we might need a new extension to do the same. So this is for the first problem statement, what we worked on. Okay. Another problem statement, what we worked on is the compiler annotation extension, as a part of which basically we wanted to generate a Java map corresponding to a Yang list. Basically, Yang is not only to define schema nowadays, Yang is also used to automate the application development. With that perspective, if we look at, we need something extra to instruct a compiler to do something extra. So for that, the compiler annotation makes a lot of sense. So using the compiler annotation during the last hackathon also, we have given some hackathon problem statements. This time also, we have extended the same to for this particular purpose. So the code is again available in the private Git. And one of the major takeaway from this is we can further extend the tool to generate some other data types like the queue, stack, and all in the future. So that's it from my side.
And I've got just 2 more slides. We've got an implementation from Vladimir on the IETF alarm Yang module. This is great because this is an individual draft. You want to show something? Oh, okay. You want? Okay.
Hi, I'm Vladimir. Last hackathon, we worked on packaging, and the result is that this project that I'm maintaining has been accepted into Debian. So it's the first tool chain, the first tool related to netconf and YANK that's being accepted in mainstream Debian. It's part of the unstable branch for the last 3 days. So if you Google netconf YANK in Debian, this is the project that I use for the development. And this time we had to do something new. So this is a new IETF draft, which is very important. Like every device needs to somehow show the alarms states. And there hasn't been such a YANK model so far. So Martin Björklund comes with this proposal, which I think is very good. I looked in detail into it, and I thought to speed things up, we need the reference implementation, which is open source, so that people can see how it's implemented. So that's what I did these 2 days. The biggest problem was because it is using YANG 1.1. So I had to use 1.5 days to implement YANG 1.1 support for the toolchain, at least as much as this module required. So then I managed to load the module, parse it, and get it loaded. So the implementation took only half a day, actually. And I have complete implementation for the basic part of the IETF alarms. So there are 3 features which are more complicated to handle, but they will be implemented later. But this is like a proof of concept. And the basic test is it is using already existing example model for IETF interfaces. So if you disconnect your cable for the interface of your computer, you get the alarm registered, and you can verify that the concept works, at least. So this walkthrough will be useful for proving that the model is mature. At least it's good enough to work for this implementation. So everything is available on the public. And yeah. Thank you.
Thank you. And in 10 seconds, I've got also an implementation on the netconf call home by Kent, and also an implementation of a mapping of different upstate. So we've got multiple ways to model upstate. And I hope a lot from this tool so that we're able to map the different type of models. Thank you.
One quick question on those tools. How much was that done here versus before?
So database search done here. From the start to finish? Yes. No, a little bit like before. The visualization started a little bit before Joe, but mainly finished this time. Alarm done here. Compilation, I started a little bit earlier. For Chin, you started this weekend. So the thing is that, yes, you could do it this weekend, but for the compilation, we did like last Monday, and the bugs are fixed already on the compilation, not the visualization tool. Thank you.
Yes. Okay. So for DNS, you need. Hold on, I'll get my. Thanks. Now we'll see if it's.
Yeah.
Yeah.
Yeah, it's right. Okay, let's see. Yeah, it works well. Yeah. All right. Okay. Let's see. It's always gather windows. Yeah, no, indeed, but and then I want to have something with arrangements. That's easier for me. Yeah. Okay, that's it. Yeah. Yep. Right. Full screen. Does it work? Yeah. Okay. Well, so here are the results. Now this is the results of the DNS team. Again, we had a good crowd, 12 people. Number of the usual suspects, but also 4 new faces. And one of them is also new to the IETF, so we were very happy they were joining our team. Okay, what were our activities? And the theme we worked upon was DNS privacy enhancement. So it's that's implementing that in the tool sets and in the software, and actually also implementation of deprive RFCs or drafts actually. How? Well, how do we improve privacy of our DNS queries over the internet? Is by, well, exposing as less information as possible by securing, encrypting your queries from the stub resolver to the resolver, from the stub to the resolver. Authenticated TLS for DNS, but also for any other connections you set up. Anti-traffic analysis padding, I will come to that later. So these are kind of number of activities we have done in the past, and also now we continue to do on our tools. So these are some of the highlights. We worked on our stub resolver, some testing, interop testing, come to that later. From the stub to the resolver, we did some padding to do anti-traffic, or to implement something like anti-traffic pattern analysis. Out of order processing, come to that later in more detail, because now it's not very clear probably. Python bindings to new functions we introduced in our library, the getDNS library. And in the recursive, we introduced, for the not resolver, ephemeral certs are added by Andre and DKG. So Stubby, the stub resolver. This is not new. People worked already on the stub resolver in previous hackathons. It's a modern stub resolver. IPv6 prefix synthesis for DNS 6.4, roadblock avoidance, DNSSEC roadblock avoidance, all kind of DNS privacy extensions. What we've done now is all this testing Stubby against a number of open privacy enhanced DNS resolvers. They run on different places, DNS OARC, at RIPE NCC, at Synodon offices. And we tested against Unbound, not resolver, and binds with Nginx in front of it. And we found some issues, but we solved that. So that's good results here. Ephemeral search and padding in not resolver, done. Now DNS over TLS can be set up with not resolver, and the EDNS 0 padding to leak as less information as possible. Okay? So that there's no any information can be inferred from the size of your answers, for example. So it's the kind of activities we've done. And very important, out of order processing of queries over TLS. So previously TLS was kind of a fallback, but with optimizations, it's not a proper fallback mechanism anymore. Because optimization, you keep the channel, the connection open, you do pipelining. And what happens? Well, we know that in real life, if there's some if there's some slow answer, is there some slow car, a tractor in front of us, everything will delay, and we want to take over. It's impossible with pipelining. So here, if you have a series of queries, A, B, C, over a pipeline, and A is a little bit later, a little bit slow answer, take longer, B and C cannot take over. They cannot be answered earlier, although they are already ready. And with out of order processing,
ABC queries are received by the unbound resolver, they can be resolved asynchronously and out of order be answered. So BC can be already answered before the slow answer A arrives and can be sent back. So that is a great improvement here. In addition to that, we also implemented a test, reliability test. So you can check if your resolver supports out of order processing for TLS. There's a service running, a DNS service, and it has an excellent feature that you can specify you can actually make the tractor as large as you want. You can make, you can ask for a 1000 millisecond delay, get Danish API.net, and it will take 1 second before you get a result. So you can test if your network of your resolver is can process out of order. So you can also then inject other queries to your resolver and see if they arrive earlier before the 1 second delayed answer. This is a kind of concludes our results for this weekend. Any questions? No? Sorry? Feedback to the deprive. Not well. We implemented the drafts and the RFCs. We don't. I think things we already encountered during implementation. We already communicated with the authors and with the deprive working group. Maybe. All right. Yeah. Yeah. Yeah.
If you repeat that into the mic, just so we have it.
Yeah. So from the results of here, we are thinking of writing or submitting a second series of documents on signaling. Yeah. Okay. Thank you. All right. Yes.
Okay, for TLS 1.3, did you guys decide you have something you want to share with us? Yeah. And are there any other presentations after this one? Okay. What type of adapter do you need? A VGA?
Yeah. Or no, we need Switchboard.
Huh?
We need Switchboard. Yeah.
That'll work. Really? Here, go ahead.
So we've been working on TLS 1.3, mostly just implementing and interrupting. So we're at draft 18 now, and we have just got this working. Basically, our local yeah.
Yeah, we could just find those.
Where is it?
It's in the Slack.
While they're doing that, I'll provide some background. We had several different stack vendors here. We had NSS, the stack that goes into Firefox, Boring SSL, the one that goes into Chromium. I've got a little stack a little Golang stack that a bunch of people have been using for testing. Hannes is working on the embed stack, and these guys are working on a stack. I don't know, Fizz.
Yeah, it's a Facebook stack.
Yeah, Facebook guys are developing it. I don't know what they plan to use it for, but we have a pretty complete compat matrix. Pretty much everything has been tested with the 1RTT handshake, and where you see Zs up there, those are things that have been tested with the 0RTT handshake, which is new in TLS 1.3, and saves you an RTT. What else, Kyle? You have something to show off?
And then just to show off. We just got Facebook working over TLS 1.3. So there you see it.
So
Now you can watch cat videos.
yeah, so
Extreme security.
so we don't have the latest version of drafts in any of the browsers, but with the compat stuff we did today or this weekend, we should have it in some of the browsers soon, Canary and Nightly pretty soon, and so maybe these guys can deploy to real Facebook servers and we can drive some traffic.
All right. Quick videos. That's all. Thanks. Great. Thanks.
Yeah, for them. Wait, one question for the TLS.
Anyone have highlights from this weekend? I think a lot of what we did this weekend was hammering out incompatibilities that have risen. We did in the last hackathon. We did a bunch of the similar compat matrix with the earlier version of the draft. There was some pretty significant changes to key schedules and message formats and things in the latest version of the draft, and everyone's stacks had kind of tried to do that differently. And so we did a lot of bug fixing and compatibility establishment during this hackathon. So that was the main focus here. Oh yeah, and of course Fizz was entirely new this time.
We didn't have any interoperability with Fizz at the beginning of the weekend, and now we have it with all, I think, 4 implementations.
Yeah, including 2 stacks that got working just as these presentations were going on. So suitably, ad hoc hackathon timing.
Okay, well, hey, thanks to those of you who presented. Really appreciate it. Sorry about the technical difficulties we had, but all the slides will be available and uploaded to the wiki, so you can see them in a little bit better quality that way. So the other thing, as I mentioned yesterday, there's the opportunity to demonstrate what you did at Bits and Bytes. If people are interested in that, it'd be good to know. Partly we want to make sure we have enough space. So if you want to do that, let me know. Another thing I wanted to check with this group, and in regards to Bits and Bytes, it is going to be Thursday. But one thing we're considering for future meetings is moving it to today, actually. So it would be this evening, maybe at like 7 or 8 o'clock. So think about that, because that's a change we may want to make, and just want to know how that would impact you. If you would see that as being really problematic because you wouldn't have enough time, or would that work out great because everything's fresh in your mind and you're ready to go. So maybe send some feedback to me and Barry about it, or send it to the list. Kind of like to get your thoughts on that, on how that would work. Who in here knows already that they want to present something at Bits and Bytes Thursday? So we got 1, 2, 3. You guys for 2 different presentations, right? PCE and ACTN? Okay, so PCE and you guys with the dev kit? And DNS? Okay. All right, so I'll check on space. I think we should be able to make that work. Just realize we won't have a whole lot of space, so don't have everyone there. And it's not the whole time behind the table, but great. So our judges will be figuring out some stuff to award. Yi, are you here? I saw you. Do you want to say a few words? Sorry? Yeah, gotcha.
Hello, everyone. My name is Ian from Huawei, and I think most part of this week I was in Lillehammer, Norway, which was very, very cold, 7 degrees Fahrenheit, with big snows over there. So when I came here, getting to the hotel is warm, and when I get into this room, even warmer. So I'm not sure whether it's the equipment, the heat, or the body heat created. So anyway, it's so good to see so many people gathering again for the hackathons. I think this is the second year, and IETF have the hackathons before the meeting, and I think it's become the part of the IETF. And also I see actually in the other standards organization or consortiums, they are also started to have the hackathon event. So I'm not sure whether this is actually started from the IETF, but you see those the hackathon events as getting more and more popular, especially for the IETF. It's so important, and not only the writing code and it can help you to prove the concept, but also writing code and it can help you to get your standards to be adopted in the market quick. And another thing I want to point out is I see more and more young kids getting involved into hackathon, especially in the local. I see a big group just a few minutes ago from local the Korean community. And also I even noticed that the people in Korea here, local, they even have their own T-shirts, the university for the hackathon T-shirts. It look pretty nice, and I hope that you have my size, and I can have one. Last but not least, this is the third hackathon that Huawei sponsored this year, and it's not the last one. So we will continue contribute, and hopefully maybe in the next couple of years we can have the opportunity to sponsor the hackathon again. So once again, thank you very much for the opportunity to us to support the hackathon event and support IETF. And thank you very much for participating. Thanks.
Okay, thank you to IE and also to just to Huawei for sponsoring. We wouldn't all be able to be in this room right now if it wasn't for that sponsorship. Also, there's some pretty cool prizes over there that we'll be giving out. And the way that's going to work is when we do have the winners, they'll be announced in kind of a certain order, and they'll have a first shot at whatever's there. And then if there's something left, we'd welcome people at the end to help themselves. We'll see how that goes. There should be some cookies for people too. So no matter what, you should get something. And with that, I'd like to bring up Yari to say a few words with us too. Yari's been instrumental in the hackathon. He was really a big supporter of it when it was just an idea to bring it forward. So we really owe a lot to Yari to making this happen.
Thank you, and thank you, Charles, also for running the show, and you've been instrumental in getting this set up. So I was really impressed today. I came in a little bit late, so I'm not sure how many I missed from the presentations, but very, very professional results, incredible results from just a few hours of working over the weekend. Exciting tech, security stuff, data models, compilers, multipath TCP, many other interesting things. So very happy to see students, the Sun Quinn Kwan team. I'm not going to get it correctly pronounced, but anyway, very happy to see you guys here. Very happy to see the altogether 25 people from Belgium. That was good as well, and new faces all over the room, of course. 4 new people in the DNS team. That's great. overall, very well done. I don't envy the judges. I've been in the judging team before, but it's going to be a very, very tough thing. How can you select between these great results? We'll look forward to what they decide. And of course, we're doing this because the essence of the internet is running code, and the essence of the IETF is running code as well. Very happy to see you guys work on this. If we didn't have running code, we wouldn't be able to get our specifications correct. And if we didn't have specifications, we couldn't have multiple interoperable implementations, which is still needed. So I want, and I think the rest of you will also want to see the open source world and the standards world work together. And with that, I'm just going to say thank you all very much for contributing and working hard this weekend. And I also want to thank the sponsors, Huawei, and I should mention that it's a sponsoring opportunity for next year. I think it will be a good thing for the industry for this to circulate a little bit. So if your company is interested in hosting this in 2017, then please contact me. Thank you.
Hi, I'm Dan York, one of the judges, and the other judges, we should say, were Ro Pelletier, Alyssa Cooper, and Barry Leva. We're over here. So we had a very hard time with this because there was some tremendous work that was done by all the different groups that were here. So the way that we would just tactically or logistically, the way we want this to work is when we have 4 awards that were here, and if the team could come up and stand up here, we want to get a picture. And then over there by the gentleman whose name I don't know, but he's against the wall right there, next to Ro, there's a table of prizes of things that Huawei has donated here, and you're welcome to go over there and choose the items that you would like to bring home with you and that type of thing. So the best overall that we decided when we looked at all the different presentations and the pieces that we chose to award to the MPTCP team. So if you guys would come on up here and all right. Oh, we need a camera. Oh. Okay. I'll take a picture. There we go. Oh, here we go. Come on. If you want to take the picture. All right. Thank you, guys. Thank you for doing that. You guys can head over there to the table over there and take your pick of what's there. So the other part of this too, and what you heard from our questions, we were trying to understand what input was going back to the working groups, what kind of things were being done, what feedback was there. The judges decided that the best input to a working group we would award to the ACTN team. So wherever they are. Come on up. Okay, come on up here. Okay, thank you very much. You guys can go on over and check out whatever's on there too. So we looked at a bunch of the different presentations that were here, and we were very pleased to see the number of different groups and the new participants and the folks that were there. We decided that the best group work award should go to the I2NSF team. So come on up, guys. Yes, come on up. Stand up here.
Thank you. Yeah.
All right. Thank you. And you guys can head on over there too. Oh, one more. All right.
Thank you.
You head on over there. And then we, one of the things we were trying to focus on was what are some of the best, the folks that were bringing new projects, new work, new things like that. We had a tough one with this because there were so many different groups that were bringing new things, new people, new areas on that. We ultimately decided to ask both of the SFC teams to come up. Where's the other one? What? There were the two. SF Kit and the other SFC team. So yeah, come on, come on up. Was there anybody else? Yeah, was it you? Where's the other, the SFC? What? Oh, they went to the newcomer session. Of course. Oh. Hey, perfect. Well, okay. All right, so you guys can head over there and then maybe head to the newcomer session, but thank you very much. So thank you to everybody who participated. It was great to see this kind of running code that goes in here. I will say it's a privilege to Charles for asking me to sit over there and judge, because I sit and I look at this and I realize how broad the range of stuff we do here at the IETF is. It's really amazing to see the wide range. So thank you all for spending a couple days here doing this. We look forward to having you back. Some of you, if you can get to the next hackathon for the next IETF, it'd be great to have you there. And I give it back to Charles.
Okay, hey, thanks everyone. Well, I still have your attention. I asked for your help with something. We have one lost item, a little, like a small leather bracelet. It was dropped here in the hackathon room. Maybe got kicked under a table or something. So if you get a chance, just when you're packing up, look around you. If you find it, bring it to me. I'll be sticking around here for a while. Okay. All right. Well, other than that, that's it for this hackathon. Thanks so much for coming and being here. It was great to see such a fantastic turnout. Right. Give yourselves a hand. You know, I'll be bugging you all for the next one in Chicago. So, hey, enjoy the rest of your time in Seoul and the whole IETF this week. Thanks a lot. And worked great yesterday, so I can't figure that one out. Okay. Well, it's not a big deal. So thank you.